Hi, I am Abdullah Emre Aca. I will present our work titled Recyclable Material Detection in Video Streams using Neural Networks. In this work, I work together with Enes Baytürk, Halil Balamur, and Levent Kutlucan from Mirsis Information Technologies, and Ulaş Vural from Visus Artificial Vision Systems. As our civilization develops, the amount of resource we consume increases. Therefore, the amount of waste generated increases at the same time. This creates new problems to be tackled. By increasing the amount of waste produced by cities, waste management has become the biggest problem for many municipalities. Correct and efficient sorting of recyclable materials needed to improve the quality of life in the city and to preserve economical values. Segregation of recyclable materials is done manually, and this requires a large number of people to work in unhealthy conditions. We aim to contribute to valuable human life with the help of technology. Due to the importance of the application area, there are many studies in the literature. Modern ANN-based methods are well enough to detect and classifying the steady objects in still pictures. There are some projects seem to working well, but on very limited image datasets, and they are not satisfactory on waste sorting tasks in natural scenes. Furthermore, we saw that similar studies can handle only one object at a time in still images. Current public datasets for this kind of work have plain image backgrounds which cannot mimic real world. We propose a novel method to detect recyclable materials in the videos that have natural backgrounds and varying illumination. First, we took some drinks made from 4 different types of containers to build our dataset. These are made of metal, glass, cardboard, and plastic. We drank these for the sake of science and threw them in the garden of our office in the morning. We smashed some of them and kicked them randomly. By doing this, we made them look like natural garbage. Then we start shooting videos. We repeat the kicking and video recording process until it got dark. Thus, we obtained images recorded in a wide variety of backgrounds and light conditions and from many angles. Totally, we had 50 videos. After that, we extracted hundreds of frames. Then, we scaled down these images to resolution of standard surveillance cameras. This makes us to work in a more realistic case, and it also increases the efficiency of our method. Next, the labeling process is done. Then, the augmentation process goes on. We subtract foreground objects. We flipped, rotate, and placed them on a different backgrounds randomly. All of these dataset augmentation process done in fully automatic way. We quadrupled our dataset. To increase the accuracy of neural network, we support it with multi-object tracking algorithm. Object detector feeds the tracker. Tracker decides whether it has seen first time or not. If it's a new object, new slot is open for tracking that particular object. In the proposed method, we use faster RCNN algorithm based on the Inception version 2 architecture. This algorithm offers high-performance object detection by using region proposals. Inception version 2 architecture reduces representational bottleneck problem of the basic batch normalized Inception architecture and works more efficiently by using factorization techniques. For each video frame, detector marks the bounding boxes of detected objects. Object Tracker gets this information and processes these detected bounding boxes to extract temporal relations of multiple objects. Then, the tracking algorithm checks if there is an overlapping between detected bounding boxes in two consecutive frames. Separating axis test method is used to determine the intersections between two rectangular bounding boxes. The tracker includes an internal voting mechanism to reduce the effect of noisy classifications. For each new frame, the voting list member is filled with estimation of the project classifier. We have realized two different experiments to show the effectiveness of our method. The first experiment aims to show the relationship between the time window size and the classification accuracy. In the table below, we can clearly see that increasing the window size always increases the F1 scores and precisions. There are remarkable improvements. In the second experiment, we wanted to show the robustness of our method against the variation in the training and the test set. 5-fold cross-validation is used in this experiment. The results show that the method performs similarly on different training and test sets. I will now show some sample video sections where our method did well. The method can successfully track and classify multiple items on different types of materials on a very highly textured background. Please note that the scene is under a strong illumination of the sun, and there are some misleading shadows, motions, and irradiances. We tested our method for different types of objects on different backgrounds. In this case, a moving can on a wooden background is successfully tracked and classified. This is a challenging scene to detect a glass material under strong illumination. It also shows that the proposed method is robust to changes on the view of the item. Now, I will show two cases where our method produced erroneous results. In this case, the method detects and tracks the object, but the classification is not correct. As you can consider, it's a really hard testing case with a transparent object on a complex background. This is the latest test case I will show. In this case, the method has not been able to track the object. It's a challenging scene with again a textured background and a transparent object. A clean and healthy environment will both increase the quality of life and protect economic values. The waste management systems developed play an important role in protecting the health of living creatures as well as protecting their economical value. Today, the number of autonomous vehicles is increasing significantly. In the near future, it is expected that wastes will be collected and decompositioned by autonomous vehicles. As a future study, it is planned to test different models and architectures for detection and tracking. In addition, studies will be carried out to detect waste with UAVs. Thank you for listening.